Yeah. All right, so this starts a new section, but you're doing the same thing with derivatives. So this is 4.1. Local is the keyword. So if I have a function, just by looking at one, I can see where I have a local max and a local min. The reason why these would be only local is we don't know, well, we do know because we know what an x cubed looks like, that this function's heading off forever doing other things. But if I'm just looking in a particular interval, then I can say I can find a max and I can say I can find a min. Well, thinking of what you know already about derivatives, where would a max and a min be?
Where it increases
At the zeros, where the derivative is zero. Or as Justin was saying, it's increasing and then it goes, and that's how we're going to kind of start to look at this, is we're going to say where it's increasing, then it goes to zero, then it decreases, or where it's decreasing, goes to zero, and then increase that both ways. So for any function f, a point P in the domain of f where the derivative equals zero, okay, or it's even undefined, is called a critical point. Okay, we're going to mainly only look at here. So a critical point is where the derivative equals zero, because we're going to get into it. All right, so if a function is continuous on a particular interval in its domain, thinking of like square roots, okay, have certain domains, then it'll have a local max or min at this particular point. Then it's a critical point, and it could even be at an endpoint of the interval if the endpoints are shaded in. Okay, not if they're open, of course. And so, and I saw in your homework you have, I don't know, there was a question, how many critical points does it have or something. So all you're looking at is you're just simply looking at everywhere your slope is zero. Okay, so that's how you're counting. If they said how many critical points in here, there'd be one. Here, 1, 2, 3, 4, because you're just looking at every single place that your slope's becoming zero. And that's the definition of. All right, so if we want to find all the critical points and where the function is increasing and decreasing for this function, so to find the first thing you do is you find the derivative. So what's the derivative of that?
3x squared minus 18x minus 48.
Very good. And I hope all of you are to the point where you can do it that quickly. Okay, if you're not, you just need to work some more. Oh, and that reminds me, I don't think I brought it. I will give you the answer. That practice sheet's just what it is. It's a practice sheet, yeah. I'll give you guys the answers to that. I just wanted to give you a little time to work on it, and then you can check your answer. All right, so set the derivative equal and then solve for the particular variable. So now we're to algebra. I probably would factor out a 3, and then I would see, can I factor this? Looks like I can. And remember, the zeros are just simply x minus 8 equals 0, x plus 2 equals 0. And so we get 8 and negative 2. So all we know right now is 8 and negative 2 are critical points. That's all we know. We don't know if they're max or mins. We just know that at x equals 8 and x equals negative 2 is a point. So first way we're going to do this is how do we figure out if it's a max or a min? We pick numbers to the left and to the right of the critical point because it would make sense, like Justin said at first, if it's increasing, goes to 0, decreasing, then that would make sense it would be a max. And so remember, at my critical point right here, my derivative, that's where my derivative equals 0, and so that's why I drew a straight line there.
Wait, is that the derivative? That rough sketch?
No, forget it.
It looks like a derivative, the maximum is at a certain point, not at a line. Wait.
Yes, okay. The only well, I think you can kind of see that. I don't know how to, I can't get this bar to go away. So that's, so now what you do, kind of weird, is you pick a value to the left of your critical point. I picked negative 3, okay, and then you plug it in and you see if your value is positive. Remember, your derivative is the slope. So that says to the left of this critical point, the slope is positive. Pick a number to the right of it. 0 is always a good number. And so if I pick 0, I can see that I get a negative value, and I'm plugging these values. Students kind of get these mixed up. I'm plugging this into the derivative because the derivative is what I care is positive or negative. Because then I pick something over here to the right, and you want to kind of stay close, okay? Meaning, fairly close within this domain, and I get a positive number. I'm going to just roughly draw very quickly what this told me plugging in values. It says it's increasing. It goes 0 at that point. It starts decreasing. It goes 0 at that point, and then it goes back increasing. Okay, so just a very rough graph to say, well, if it's increasing and then on the other side it's decreasing, that means I have a local max. If it's decreasing and then it starts increasing on the other side, then that would tell me that that's going down for a minimum. And so certainly more nicely drawn is this shows you, and a lot of times I'll say, give me the critical point, and students will always answer our critical points, -2 and 8. And that's not correct. That's the x value, but I want the point, meaning then you would go back and you would plug this value into your original function. And this, of course, is where it's nice to be able to graph it and see, put those points on the graph and see that those are the 0 points, okay, for your slopes. All right, so the first derivative test for a local max is what we just did. It changes in direction at a critical point, okay, meaning that our first derivative is negative, so it's decreasing. We find our critical point where our derivative equals 0, then it's increasing, decreasing, 0, increasing, so we have a minimum, increasing, 0, decreasing, so we have a maximum. So this is called the first derivative test, just by looking at values to the left and to the right of the critical point. Now, you can always use this way, but, well, I don't want to say there's an easier way, and that's what I'm going to show you the next way. The next way is only easier if derivative is easier, which a lot of times isn't easier, okay? So what I'm going to do here is I'm going to say, well, the second derivative test is I can actually figure out if my function is concave up or concave down. We learned how to do that with second derivatives, right? But there will come a time that there's no way you want to take a second derivative. It's just a horrible, way to do it, and so you just pick values. I don't care either do it.
I finally understand that now, the second derivative.
The second derivative for the
I
concave
never
stuff?
understood that at all, because it's like the reverse of that, I would say. But
Well, and you also think because it's acceleration, how the acceleration is changing. Yeah, well, good.
But I see it, but now I see it like if it's concave up, then it's more like that.
What's funny is I have my students got in my mind that if it's happy, it's a min. If it's sad, it's a max. I don't know. They got into my head with that. All right. Well, here is an example of finding a second derivative is easy, right? So I would do this. Who would pick values to the left, values to the right? That took too long. Pick the derivative, and then plug in the critical point into the second derivative and look to see if your values All right, the only warning here is not every critical point of a function is a local max or a min, because think about this is x cubed, and it actually goes flat right there. But notice it's not... Man, yeah, it's very, very light. I guess these blue graphs aren't really happening for you guys. Okay, and so what's happening there is if you notice, it's never completely concave down or concave up, and in fact, it's something that we get into in the next section.
Wait, quick question.
Uh-huh.
Are critical points also defined as say undefined or no?
That's in this, and it could be, yes, a critical point could be somewhere that's undefined.
Like, let's say like 3x squared, it can't be 0. That's true, right?
It could be the flat part of it, the vertex of it, yeah. Yeah. Maybe. All right, here we go, Chris. Pay attention.
Oh, okay.
Suppose Chris and Vivian are applying for the same job. Vivian wants the job so badly, she stabs Chris with a needle and administers a particular drug in Chris's bloodstream so he will fail the drug test for the job. I told you you would like it.
Sabotage.
It's not good. Dr. Rafiki performs an experiment to find the percent of concentration of the drug in the bloodstream so Chris will know when the percent is beginning to decrease and he can be ready for the drug test. Dr. Rafiki finds that T hours later, and I did not put what he was holding in that picture.
That was anatomy and physiology. That was fun.
All right, so T hours later, the percent of concentration of the drug in the bloodstream can be modeled by this function. So if we can put in, how many hours later, we can figure out what percent is in the body. Kyle, what is this? Everybody wears wigs on their Facebook? Kyle tells Chris, don't worry, dude. After 1 hour, the concentration of the drug in your bloodstream will start to decrease. Just sit on the soccer field for a few hours and you will be fine. Now, this is the funny part. Miss Amory, she has no bad pictures on her Facebook. So she says, don't listen to Kyle. He sits on the back row and never pays attention in biocalculus. What does he know? And Kareem says, hey, I'm on the back row and I know everything. I thought that picture was like, what? All right, so is Kyle correct? Is Kyle correct that the concentration of the drug in the bloodstream will basically top out at 1 hour and then start? So let's see. So basically we have a function. Remember what a derivative is. Yeah, I've beat it into your head, slope, 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 slope. But it's a rate of change. So we're looking at a rate of this drug leaving Chris's body. And hopefully he gets the job and Vivian doesn't. Let's write. I kind of said this in my class this morning. Because students typically hate word problems, I like to write things down that says what this means. This is the percent of the concentration, okay, of the drug. And then my T is in hours. And I just kind of do that on the side because then I get finished and I'm like, what? I got an answer, but I really don't understand what it means. So what I want to do is I want to see where this is maximizing or minimizing. I don't know which one yet. So I'm going to find the critical point. So the critical point is we find the derivative and then set it to 0 and solve for t. So let's just find the derivative first. What rule are you going to use? Quotient. Okay, because that's a quotient. This is a good example of today's quiz problem today. So it says leave the bottom alone times the derivative of the top minus leave the top alone times the derivative of the bottom.
What's with these brackets?
That's me, and the reason why I'm afraid students are going to not distribute that negative sign. That's just, I've kind of gotten to a habit of doing that. And then I'm going to square the bottom. Okay, so again, I'm hoping everybody's to this level. The derivative of 5t is just 5. The derivative of t squared, bring the 2 down, so that's just 2t. And now I just kind of multiply things out, so I'm going to get 5t squared plus 5 minus 10t squared over t squared plus 1 squared, which is going to equal minus 5t squared plus 5 over t squared plus 1 squared. Okay, so all I'm doing is finding the critical point, which is finding the first derivative, and now I'm going to set this equal to 0 plus 5 Now, I don't know why this is weird for some students to understand. This means the same thing as that. Why? Are you okay with that?
Yeah. Oh, yeah.
Because all I'm doing is I'm multiplying this on both sides and there's a 0 there. It's like, well, where did that go? It disappeared. Well, no, if I multiply both sides by that parentheses, it cancels on this side, and then, of course, that becomes 0. Okay, it's just kind of a weird, I don't know, it seems weird for some students. Where did that go? And so now all I'm doing is continuing, and so this becomes 5 equals 5t squared. I'm just solving it for,
-5.
I moved the -5 to the other side.
Oh,
And so just to make it positive, and so I'm going to end up with dividing by 5. So I get t squared. When you solve this for t, what do you get?
yeah, plus or minus 1.
Very good. Technically, and we get out of the habit of doing this, you should be doing the plus or minus. However, we're talking about time, and it's only going to be the positive value. And a lot of times that will happen in this class, is you'll just throw the -1 away because it makes no sense. We're not going back in time before Vivian stabbed Chris. This was such a mean thing to do.
Yeah.
But Chris is German, I didn't do anything to him.
All right, so we found the critical point. We need to figure out by finding the second derivative, and let me rewrite the first derivative here. Minus 5t squared plus 5 over t squared plus 1 squared. For practice with the quotient rule, we're going to go ahead and find the second derivative. But many of you would say, oh, I'd rather plug values in, to the left and to the right.
Ridiculous.
Because, yeah, this is going to be a crazy one, but it's a good practice. So the second derivative, Justin doesn't like my brackets. All right, so the second derivative says leave the bottom alone times, what's the derivative of the top?
-10t.
Okay, good. And then now I leave the top alone. And what's the derivative of the bottom?
That will be 2 parentheses t squared plus 1.
Slow down, slow down, slow down, slow down. 2 parentheses t squared plus 1 times what?
2t.
Very good. I'll explain that in a second. And then the bottom squared. So what Justin did is, I'm guessing what I do, you can just look at it. You don't have to do the whole, but let's do the whole u thing. So what he did here is I said that u equals t squared plus 1. So y is just simply u squared. The derivative of u with respect to t is 2t. The derivative of y with respect to u is 2u. That's that 2t, and that's the 2u. Okay, but he's gotten, like I do, where you look at it, and even Chris was saying that it's easier. Take the derivative of the outside, so that 2 came down here. Subtract 1, so that's that piece. And then take the derivative of the inside, which is the t squared, which is that. Okay, and now it's to the point where you're going to use your calculators anyway. You can make this look better, but what you're doing is you're wanting to plug in your critical point. So remember, that was our critical point, and you want to see if you get a plus or minus answer, okay, positive or negative. If you notice right here, when I plug in a 1, what's going to happen? That becomes 0, and so nicely, that whole piece goes away. So it's not as bad as it first looked. So plugging in 1, I'm actually going to get negative 40 over 16. Okay, again, looking at this, if I plug in a 1 here, that becomes 1 plus 1, 2 squared, 4 times negative 10, that's times 1. That's where my negative 40 came from. All I'm doing is plugging in a 1 for t. That went away because I plugged in a 1, that became 0. Okay, so that piece went away. And then I plug in a 1 at the bottom. Again, I didn't even have to do anything here because whatever this gives me when I square it's going to be positive. So the bottom's positive. Once again, I could care less what that number is. That's all I'm looking at. Yes?
So So just to make sure I have it right, we could also just plug in 0 and 2 into the first.
Exactly, and and the 0, that's golden, right?
Yeah.
Yeah, and that's what I was saying. For most of you, you probably would have just went back up there, and as Corey said, plug in a value to the left, plug in a value to the right. This is a good example of when that probably would have been easier.
Okay.
But I was just trying to bore you with a long quotient rule.
That's what I figured.
Yeah, okay. All right, so in other words, this is less than 0, okay, meaning it's negative. And so, in other words, we have a max at that point, at that critical point. And this is where they basically told Chris it's going to max out the first hour. Where'd that come from? All right. And so, as you can see here, if I can kind of dot the lines, you can see that that's a max, which would make sense. And then after the first hour, the drug starts leaving his bloodstream. Okay, so, and in fact, whatever group gets the Breaking Bad one, this is kind of what you're going to do in the Breaking Bad group, is to see a drug, how it leaves the system.
So how's
Okay?
that Pokemon one coming along?
Huh?
How's that Pokemon one coming along?
Slowly. I got watching American Horror Story, and now I can't go back to Pokemon.
You can always go back.
But Pokemon,
Yeah, I was just like,
You just do the intro of the first season, and you're just